Alright then, happy Halloween. Maybe, I don't know when this video is going to go live, probably around Halloween. I've had some big problems recently with computers, so we're going to get straight back on track with learning laws of indices. And I'm actually really wanting to show you where they come from a little bit so you can remember them. Then we're going to go in and do some examples. So let's get rid of this and yeah, let's get cracking. Right then, so an index, or indices is the plural, is just a power. It's when you've got something like 2 to the power of 3 or 2 to the power of 7. That 7 is an index. Plural indices is just the power. Now, we've got lots of situations where you can simplify how you write the powers. And let me start off with this one example. Dropped a pen. If you have 6 squared and you times it by 6 cubed, then what you get, well, 6 squared is 6 times 6. And 6 cubed is 6 times 6 times 6. So then you have 5 lots of 6's. That is just 6 to the power of 5. What you take from that is a law of indices and generalize it to any situation where if you've got a to the power of n and you times it by a to the power of m, then all that equals is a to the power of n plus m. You're just adding them. It was 2 add 3 is 5. Easy as that. So that's if you times into like things. These two numbers have to be the same. That's why I've written a and a there. But what if you're dividing? What if you say I have 6 to the power of 3 divided by 6 to the power of 2? This is 6 times 6 times 6 divided by 6 times 6. Well, if you times in by 6 and then dividing by 6, may as well just cancel them out. Likewise for that one. This is just 6, which is 3 minus 2. So we get a new little rule here, which is a to the power of n over a to the power of m. Get this right. Then that equals a to the power of n minus m. That's a nice little rule. And we can use that in a second. So we're going to continue on this little trip, and if we've got something like 6 squared, and then we're cubing that, what that is equal to is 6 times 6 cubed, which is 3 lots of that, and I'm going to write it out. 6 times 6 times 6 times 6, which is 1, 2, 3, 4, 5, 6, 6 to the power of 6, which is 2 times 3. That's another bloody rule there. So what you get is, if you've got a to the power of n, and you do all of that to the power of m, that's the same thing as a to the power of nm, or m, and then to the power of n. It's all the same stuff. That, my friend, is a nice result. Let's keep going. Looking at this one, what would happen if the number on top was smaller, like this? Well, in the exact same situation, we'd get this, which once we cancel all these down, we get 1 over 6. But also from our previous rule, we minus them. That is equal to 6 to the minus 1. Now that is another property of indices, where if we have anything to the power of minus 1, that is exactly the same as 1 over. I'm going to write that a bit better. So how many have we got? 1, 2, 3, 4. We've got a few more to go. Now this next one's really nice. So we've skipped one, actually. What if these two powers were the same? 6 squared over 6 squared, that is equal to 6 times 6 over 6 times 6, which is equal to, cancel, 1, which is equal to, from our previous rule, 2 minus 2 is 0, 6 to the 0. Again, we get another little property, which is always true anything to the power of 0 is just 1. Now that is really important. So that takes us up to 5. This last one is gorgeous. It's all about what you times by itself to get another number. So, how are we going to do it? Imagine that these weren't whole numbers. If you had 6 to the power of a half, you'd be like, what the hell is 6 to the power of a half? Well, we can figure out by squaring it. If we square it, then we get 6 to the half times 2, which is 6 to the power of 1, which is also equal to 6 to the half times 6 to the half. Because that's what that is. We're squaring it, we're timesing it by itself. So what we get is this little result here, that 6 is equal to 6 to the power of a half times by 6 to the power of a half, which must mean that 6 to the power of a half is the square root of 6, because that's the property of a square root, is that when you times it by itself, you get that number under there. So we get this nice new little rule, which is a to the power of 1 over m is equal to the mth root of a. So whatever that m is, it's the mth root. So if it was 1 over 3, third root, 1 over 4, fourth root. Easy as that. We can generalize that one step further by using this rule, whereas if you're gonna like take that to the power of n, then you get that. And that's nice, that. So these are all the laws of indices. Now, in like a normal A-level course, or even most GCSEs, you have to remember these, all of them. So just remember that there's 6 of them. Where's my red pen? And you can work them out if you forget them, because it's just pure common sense. Now, this isn't an actual proof of it. This is because we know what proof is. This is just proving them in one situation. Now, to actually prove them, you would use a further maths technique, which is called proof by induction. All right? Sweet. So, let's actually have a go at using some of them. Now, I'm going to have to get rid of some of that, but we'll keep all this down that side. Hopefully that'll be all right. All right then, this is our example. Simplify x times x to the half. This is just a bog standard kind of example. I'm going to actually stop here because I haven't actually explained these two words of what this A is and what the N and M are. So let's just backtrack a little bit. Right. So A is the base, and that base can be any real number. Now N and M, they are the indices, they're indexes, and they similarly can be any real number, but in A-level maths you'll pretty much only see them as quotients. So I'm just going to write any real number there, just for the sake of simplicity. Now what that means is that you can apply them to absolutely any situation that you come across in A-level maths. Right, back to this example. Okay, x times x to the power of a half. All we're going to do is we've got x and x. The base is the same, so if the base is the same, we can apply this rule here. That rule is just that we add them because we're timesing them. So we've got x to the power of 1 times by x to the power of a half. And that's just x to the 1 plus a half, which is equal to x 3 over 2. Job done. Easy. Let's do another. Okay, this time it's a little bit more tricky. We've got 100x to the power of a 4. So it's just x to the power of 4. And then we've got all of that to the power of minus 1 over 2. So we're going to look at these in two different situations because we can break this up. We're going to say that this is equal to 100x to the power of 4 to the power of a half then all of that to the power of minus 1. The reason why we're doing that is because it makes it like digestible. We can break it up. And all we're doing is we're applying this third rule, because minus a half is the same as a half times minus 1. So that makes sense. After that, we can apply this in here. So we've got 100 to the power of a half, x to the 4 to the power of a half. Then on the outside, we've still got that minus 1. 100 to the power of a half is just 10. It's the square root of 100. It's just 10. You can put it in your calculator if you didn't know that. X to the power of 4 times, then to the power of a half is the square root of that. But we don't need to think of that. We could just do this. A half times 4, well, it's 2. So we get x to the power of 2. And that's all to the power of minus 1. If it's to the power of minus 1, that just means that we're going to do this. It's just got a 1 over it. So all we need to do is say that that equals, let's tidy this up. This board's really wobbly at the moment. Bam, that's it. Job done. Okay, let's do another one. Right, we've got another one here. So these two little dash bits like this, that just means like, I'm repeating that bit. We're doing simplify, simplify, simplify. That's a very common question with indices in A level. So we're going to simplify this. It looks a bit nasty, but we're going to get straight involved and we're going to be like, well, there's an A in every single term. If there's an A in every term, we can just cancel all of those out. And we're left with 12 b to the minus 2 over 8b, and then 16 on the top. So what you might want to do here is split this up into two fractions. Doing that isn't any amazing leap. We're just being like, well, we've split it up into two because it's the same denominator. You can do that. That is easy. That's like 10-year-old maths. Anyway, so we've got this 12 divided by 8. 12 divided by 8 is the same as 4. No, 3. No, common factors. We've definitely got a common factor of 4, so it's 3 over 2. 3 over 2. B to the minus 2 divided by b. Well, it would be this one. We're going to do minus 2 minus 1. But that's going to look a bit ugly, so it would be b to the minus 3. But that minus 3 means that it's 1 over. So it would be that. 3 over 2 b cubed minus 16 over 8 is just 2. 2 over b. Bada bing, bada boom, that's another one. So that 3, it's annoying me being off to one side. Let's put it there. Isn't that nice? It simplifies down much nicer. If you wanted to put that over one denominator again, you could times this by b squared and 2b squared. So that would equal... That's easy enough, if you wanted to. Now this is quite easy. All you do is you apply these rules to that. We're going to do one more example, which is a bit more of a brain scratcher. So let's do that and then see what happens. Right, I like this question. This is a real brain scratcher. What we've got is find x and y when 4 to the power of x times by 3 to the power of y equals 24 to the power of 8. To get started here, we can't use any of these because the base on each of these is different. It's not just a, it's 4 here and 3 there. We can't actually make them the same because the prime factors of this is 2, and that is a prime. So we're never going to get this two bases to be the same. So what we need to look at is this right-hand side. Now, I said prime factors, and that is actually something that we're going to have to use. I said it in a previous episode, you will remember that. So, we're going to express 24 as a product of its prime factors. So we could do our little tree. Where can we do that? Twelve and 2, 3, 4, 2, 2. So 24 can be expressed as 3 times 2 times 2 times 2, which is 3 times 2 cubed. So we can write this as that. Now that's looking nice already because we've got a 3 here and a 3 there. So if we sort out that, the power of 8, we get three to the power of 8. So that means we've got our y already. Times 2 cubed times by 8. Now, am I going to have enough room here? Just. So this is 3 to the power of 8 times by 2 to the power of 3 times 8 is 24. So we've got y, tick, but we've not got that x. There's one last little thing to do. So we want the base to be 4. We can get 4 from 2 by just squaring it. So all we need to do is quite simply, I don't even know if that's going to be on the screen there. It might be. Let's just finish it over here. That's it. So we use this rule here to say that 2 to the power of 24 is the same as 2 squared times by 12, which is 4 to the power of 12. So what this means is, I'll do this in a different colour. X equals 12, y equals 8. And that is it. That is it. So you really need to remember these, and remember that A is the base, it's any real number. N and M are the indices, they are also any real number. You're probably only going to see quotients though, so like 1 over 2 or just 3 or something like that. Simplify stuff, simplify harder stuff, simplify fractions, or actually use a bit of brain scratching skills to find some actual usable stuff. Yeah. All right, nice one. Don't know why I just opened that. This was a difficult video to make because genuinely, computer died and I had to re-record it, and I kind of really didn't want to, but we're back on track, all right? This is it then. See you next time. This is a real skull.